Hey guys, welcome back. So today we're having a premium Patreon subscriber only tutorial. Here's what we're going to be looking at. Like I said, this is just for you guys, my premium subscribers. You're the fucking best, and it really means a lot to me that you guys are supporting me like you are. So what we're going to be doing today is taking our caustic simulation and piping that into the particles GPU that we worked on in the last tutorial. It's pretty straightforward, so it should be pretty fast, but there are a couple nuances that I want to highlight. I'll also be supplying this project file um, complete with the annotations that you see here, which pretty much explains everything that I'm changing as well. So it should be pretty easy to follow along. Um, so without further ado, I will jump into things. So we're starting with this is just the particles GPU component that we built to at the end of the last project. So you can just go grab that from either the project file or if you followed along and built it already, just use that. We're going to be using the Caustics component that we created in my Caustics tutorial. I recommend you do parts 1 and 2 because some of the improvements from part 2 are going to be necessary here. And then just as an aside, an added bonus for you guys as the premium subscribers is going to be you get my slightly more decked out caustics component that has a couple other pieces of functionality, including a input for remapping, an input for color, and just because I really like it, I'll show you this other component or this other feature, which I'll just throw on top of a background real quick. So the other part of the caustics component that you'll get is the ability to switch it to sphere mode and then generate caustics in a spherical pattern. Um, I really like the sphere. I think it's pretty awesome. So all you got to do is click this, change it from plane to sphere, and you guys should be good to go. So quick aside, without further ado, now we'll get into the meat of things. So yes, I will get rid of this. I'm just going to keep this set up as is because all I did was take the component directly from the end of the last tutorial and add a different image from a trip to Japan. Um, and then this select top, which we'll come back to in a second. So let's first drop in a caustics component. Actually, I'm going to not delete everything. I'll just delete the stuff in the middle. And I'll keep the caustics component here. So again, this will be available. So just grab this, and then we are just going to drop down one noise for our surface input, and we can just give ourselves a view here so you can see what's going on. Okay, just going to drop down the surface input. We're not really going to care how this actually looks, but just so you can see changes as we tune this. 32-bit float, 512 by 512. Monochrome is off. We want our offset to be 0. We want our amplitude to be a bit higher. Probably some more, less harmonics, more spread. And something about like this is probably going to be looking decent. Actually, I'm going to go back to just standard here. Cool. So nothing too crazy here. And that's pretty familiar to us. We'll copy and paste this noise. We will turn the amplitude down to 0. Drop a constant in. This should be familiar from the last tutorial. 0, -1, -1 and 0. Make sure that's a 32-bit float. Pipe that into the noise. Set the noise to input minus noise. Wire that into our light distortion. And if we give ourselves a little bit of animation, cool. We can see that indeed things are working. And if we apply light distortion, we get a little bit of light distortion. Cool. So I've already set up a couple parameters on my parent. So I'm just going to map those to my noise here. Surface amplitude, light exponent, and light amplitude. Cool. So now we can control everything from here, and that's great. So now if we jump into Caustics real quick and get rid of this, what we will remember is that what we're really doing in this caustic simulation is outputting positions, and then we're instancing these points with those positions. So our positions are all we actually need. We don't need to worry about any of this rendering. And actually, I'm going to leave it, but you could just take out all of this rendering, although it shouldn't really matter because we're just going to be using this output here for the position. So the only thing that we're going to actually need to change about this is add one thing to our pixel shader. So grab the caustic pixel shader and let me get this over here. All right, so this is our caustic pixel shader. You will notice that the sphere implementation is added in here because I'm intersecting with a sphere, and then I have some if-else statements in the body so that I'm only compiling the amount of code necessary. So if you're not familiar with GLSL, what you can do is use this hashtag if, hashtag elif, hashtag endif, and whatever you put in between here is only going to be executed and actually compiled, and therefore contribute to your performance overhead if this conditional is evaluated to true. So anything you put in here will simply be skipped over if the evaluation is false, which makes it really handy for running different scenarios or states through the same shader while not giving up any performance. So I'm not going to go into the sphere specific code, but you can take a look and it should be pretty self-explanatory. Now, the thing that we need to add, which I think will be more apparent if I give us some more gain to play with, is going to be a treatment for nans, because here, if I turn this way up, you can see even more. So if we hit D to look at the pixel colors, we can see that some of the positions are evaluating to nan or not a number. And I believe the reason for this is because we're trying to take normals of a surface with cusps. And so that means that we're evaluating to null or nan because you can't take the normal of a cusp. So there's a pretty easy fix. And I'll just set this back to something reasonable before I leave. And I'm going to parameterize the gain here too. Cool. So now if I go back up and I will give ourselves more gain so that we can start to see some of these breaks appearing here. And now I'll go back to GLSL. So all we need to do to fix this is say color equals clamp 0, oops, color 0, 1. And this will simply clamp any nan values to 0. So if we can find one and check it out, oops, there we go. You'll see that down in the bottom, we're seeing zeros for all those values. So that's great because now we're not evaluating things to a nan. I'm going to turn this gain back down to something reasonable. All right, so now that's the only thing we need to change with our caustics. And now we can connect all of our dots. So as I mentioned, or maybe I didn't mention, but we're using positions, right? So this output data is positions. We need to convert the positions to something that we can use as a velocity map to power our particle system. So we can do that either using a slope or using a normal. And I'm going to just wire both of them into a switch. I've already parameterized this component, so I'll just wire that in, and then we'll make a null and drop that onto our select. So now we finally have some velocity going, which means we can start to look at our particle system instead of our positions. Now, there's a couple things that we need to tweak. One is setting this to vertical luminance and blue to neutral, as well as the 0 point to 0. And then you're going to make the slope strength something a little bit higher, maybe like 50. Actually, I'm not sure if that matters since we're normalizing. So we don't actually have to do that. But we do want to make it a 0 point. And I find that making it something like 50 or even 500, again, we're normalizing so it doesn't matter. It just makes it easier to see. And I like being able to see that. And then if we switch to our normals, we can see that the normals are also being applied. Although we probably will want to reorder our normals so that we have the blue and the green are flipped. So that was actually wrong. Yeah, so what we want to do is just pre-add by 0.5, and that will now give us something that is looking pretty nice. So now we have our normals and we have our slope. Two different ways to express this position data as a vector field. And that's already looking pretty good. So if I turn our gain up again, and we keep this position data open and looking, we can see that our, yeah, there we go. We can see that our data, even though it's not evaluating to nan anymore, we can see it's still evaluating to zeros as we would expect. We're seeing some clipping and some artifacts on our actual particle system, which is obviously not what we want. So we will handle that very easily. So what we're going to do is just change the alpha in our slope to horizontal RGB average. Then we're going to take a GLSL, edit this. We want the incoming color, and then we're going to simply say the color is going to be set to 1 if the alpha value is equal to 0. Otherwise, we're going to set it to 0. So this is a pretty handy one-line conditional. So we can say, what this is saying is color variable is going to be equal to color. All right, yeah, so it's going to say color is equal to 1 if this statement evaluates a true. So this is kind of read as the question mark with a if operator. So if color alpha channel equals 0, then color variable is set to a vec4 of 1, and if not, it's set to a vec4 of 0. So what that gives us is a nice mask that's going to have values of 1 wherever our pixels are 0 and clipping, and a 0 otherwise. And we can use that, if we move this back here, I'll actually pipe this in because our normals will be clipping as well. We can use this in conjunction with a matte and just any other noise, really. So first, I'll just pipe this noise in so we can see what our placeholder is going to look like. Make sure it's 32-bit float. And cool. It doesn't need to be too crazy, so we can just leave that there. Pipe this in now. Put our null in as input 2, or sorry, our noise in as input 2 for this mat, and then our GLSL as the mat channel. Then we just switch our inputs, and we'll see that anywhere that there's a tear in our output, we're just going to be using this mat to replace those values with values from our placeholder lookup, which results in a nice, smooth, anti-aliased output here. And that is basically everything that we need to do. So if we come up to the top, then we can, I guess I don't even need this. Then yeah, we can just take a look a little bit, and we can see that as we change our parameter values, we do get a pretty decent reaction and change in our visual effect, which is pretty cool. And there's definitely a ton that we can play with here. So with that, I will leave you, and I hope everybody enjoyed this tutorial. Like I said, it's just for you guys. I appreciate all of the support, and I wish you luck in all of your creations. Please share with me what you guys are working on, by the way. It would be really cool for me to see. So, goodbye. I'll see you guys next time.